Could the very air you're breathing, I mean the oxygen that life like us depends on, be connected not just to the sky, but deep inside the Earth, to its molten core? Today we're doing a deep dive into some, well, pretty groundbreaking new research. It suggests this really surprising link between Earth's core, its magnetic field, and yes, the oxygen in our atmosphere. Our mission here is to unpack this study, looking at the article, A Secret Link Between Earth's Core and Oxygen. We want to see how it sort of reshapes our whole idea of what makes a planet habitable.
Yeah, and what's really fascinating, I think, is that this isn't just about, ancient history on Earth. It raises some really big questions for how we look for life on, well, other planets in the future.
Okay, right, let's unpack that.
Yeah.
So we've known for a while that deep inside the planet, you got molten iron and nickel churning around the solid inner core, this sort of counterflow thing relative to Earth's spin. That whole setup, that engine, is what we call the geodynamo.
Exactly, the geodynamo. And that's what generates our magnetic field, the magnetosphere. We've always understood its role as this vital shield, protecting life on the surface from nasty cosmic rays and solar radiation. Absolutely critical.
And we've also thought for a long time that this shield, the magnetic field, is key to keeping our atmosphere, stopping it from being blown away by the solar wind. You always hear about Mars, right? How it probably lost its atmosphere because its core cooled down, the magnetic field weakened, and poof, the air just stripped away.
That's the classic example.
But okay, here's the twist. What if the magnetosphere isn't just shielding us? Could it be, actively involved in the oxygen levels, in breathable air itself? That's the really new idea here. And this is where it gets really interesting, with this new NASA research suggesting a connection much, much deeper than we imagined.
Yes, exactly. The study was led by Wujie Kwang, a geophysicist over at NASA Goddard. He worked with scientists from the University of Washington and the University of Leeds. And what they found is, well, pretty remarkable, a strong correlation between shifts in Earth's magnetic field and big changes in atmospheric oxygen levels. And this goes back like 540 million years.
500 million years, wow.
It just got published June 13th, 2024 in Science Advances. And the implication really is that our planet's deep interior might directly influence the chemistry of our atmosphere. If you think about the big picture, this could, fundamentally change how we think about planetary habitability. It's a potential game changer.
Okay, my mind is slightly blown. How? How could they possibly know what the magnetic field and the atmosphere were like 540 million years ago? What tells you that?
It's actually a really clever method. Think of Earth's rocks, the geological record, as kind of time capsule. When magma cools and solidifies into rock, tiny magnetic minerals inside it line up with the Earth's magnetic field at that exact moment.
Yeah.
So they become like tiny fossil magnets, recording the field's direction and strength from way back then.
Fossil magnets. I like that.
Right. But here's the really neat part. The chemistry of those same rocks also tells a story. It reflects the amount of oxygen that was in the atmosphere when they formed.
Wait, so the same rock gives you both the magnetic field data and the oxygen level.
Exactly. It's this dual archive function, you could call it.
That is elegant. So you can actually build a timeline showing how both the magnetic field and the atmosphere changed together over millions of years.
It really is. And Wujie Kwang, the lead author, put it nicely. He said something like, these two data sets are very similar. He points out, Earth is the only known planet that supports complex life. The correlations we've found could help us to understand how life evolves and how it's connected to the interior processes of the planet. Makes sense, right?
It does. And they found that big swings in the magnetic field strength lined up with major rises and falls in oxygen.
Yeah, that's the core finding.
And critically, this lines up with the Cambrian explosion. That period, 540 million years back, when complex life suddenly, exploded onto the scene. Precisely. The timing is uncanny.
So what does it mean? Is the magnetic field somehow controlling oxygen? Or is the oxygen level affecting the core? Or maybe is something else driving both of them?
That's the million-dollar question, isn't it? And the leading theory right now leans towards that last option, a shared underlying cause. Think about massive geological processes like plate tectonics or continents drifting around. These huge movements could potentially affect both things at once. They could stir up the molten core, changing the geodynamo and the magnetic field.
Okay.
And they could also influence surface processes that control atmospheric gases, things like, volcanic activity releasing gases or how much organic carbon gets buried, which impacts oxygen.
So one big geological process could be pulling the strings for both the core's behavior and the air's composition. That seems to be the most plausible connection they're exploring. Benjamin Mills, a biogeochemist from Leeds who was involved, said something similar. He mentioned this correlation raises the possibility that both the magnetic field strength and the atmospheric oxygen level are responding to a single underlying process, such as the movement of Earth's continents.
Okay, and this is where, for me, it really expands beyond just Earth science. Thinking about astrobiology, the search for life elsewhere, this seems huge.
Oh, absolutely. This doesn't just rewrite bits of Earth's history. It could really influence how we search for potentially habitable planets out there. It suggests maybe there's another item on the checklist for habitability that we haven't paid enough attention to.
Meaning?
Meaning, well, if a planet's internal engine, its core activity and magnetic field, is crucial for maintaining a stable, oxygen-rich atmosphere over geological time, then just being in the habitable zone, the right distance from the star for liquid water, might not be enough. You might also need the right kind of active planetary interior.
So a dead planet, geologically speaking, even in the right spot, might struggle to hold on to the kind of atmosphere complex life needs.
Potentially, yes. It raises this really important question for scientists looking at exoplanets. Do we need to consider the planet's internal structure and potential magnetic field more heavily?
And I gather the research isn't finished. They're planning to look even further back.
That's right. They want to push this timeline back even further into Earth's past, before the Cambrian, and also look at other key atmospheric gases like nitrogen, trying to see if this core atmosphere connection is even broader, maybe revealing a more complete blueprint for how a planet becomes and stays habitable.
So wrapping this up, the big takeaway today is this incredible idea. Our planet's deep, fiery interior might be fundamentally linked to the air we breathe, and maybe even to the existence of complex life itself.
Yeah, if you sort of step back and look at the big picture, this research hints that the secret to life isn't just about the surface conditions or the sky above. It might actually be deeply connected to the planet's heart, its core. It's quite a profound thought, really.
It really is. So maybe something for you, the listener, to think about. How does this change the way you see the ground beneath your feet? And what other hidden connections, these deep links between different parts of our planet, might still be waiting to be discovered? Things that could tell us even more about how life arises, not just here, but potentially out there among the stars.